This Zoom session is being brought to you by the fractal Gold Swirl A. All right, for today, I'll go back to a one class, one section of a class meeting pace. Okay, and that should cover the rest of the assigned material by the break. And afterwards, I'll be going over extra credit problems and so on. And perhaps give you a little more slack on the matter of taking quizzes in final. We'll deal with that in due course. Okay, today we do the complex plane and de Moivre's theorem. Now, okay, the complex plane involves complex numbers of the form a plus ib. I is the square root of -1. Its square is -1. That makes it a quote imaginary number. And a is the real part, b is the imaginary part. A plus ib is over a and up b. Now we do addition in complex numbers by combining like terms. A plus ib plus c plus id is a plus c, the real parts add up, plus I times b plus b. B, the imaginary parts add up. Same with subtracting them and multiplying by a real number. Everything happens in the real and imaginary parts happen separately. Now, if you're going to do multiplication in complex numbers, you have to use FOIL, and I squared equals -1. A plus IB times C plus ID. Okay. AC is the first part. Outer is A times ID here, IAD. Inner part is IBC here. And last part, IB times ID, but since I squared equals -1, it becomes -BD. Then you combine the real parts, AC minus BD. Then you combine the imaginary parts, I times AD plus BC, like right here. Now, okay, adding is pretty simple in complex numbers. These things add and subtract in parallel. This part with the complex multiplication, it gets a little more gnarly. Well, okay, it turns out that if you go by what are called polar forms, it's actually quite easy. So imagine a complex number, a plus ib. Its rectangular form is over a and up b, a plus ib. But let's look at its polar form, which is to say how far out you go. That's r, and the angle theta it makes with a positive real axis. Those are polar coordinates, and they specify a point, just like rectangular coordinates do. Now, this is a right angle triangle, and by fairly routine right angle trig. A over r is cos theta, so A equals r cos theta. B over r is sine theta, so B equals r sine theta. So A plus IB is r cos theta plus r sine theta. And what do you know? We can factor out an r, and you get z equals r times cos theta plus I sine theta. And now we've separated the r and the theta into two parts. Multiply. Here's this plain old r. Here's this thing, cos theta plus I sine theta. And what is that? Well, cos theta plus I sine theta. It has a name, CIS, cis theta. Cis theta is in the unit circle in the complex plane. You go around an angle theta. And as theta goes to the real numbers, cis theta spins around and around and around the circle. So you have the rectangular form for a complex number, a plus ib. You also have this polar form, r cis theta. Now this is actually helps with multiplying because if we take cis alpha times cis beta, then, well, let's work it out. Cos alpha plus I sine alpha, so cis alpha. Cos beta plus I sine beta, cis beta. You multiply it out and do a bunch of do complex arithmetic, blah blah blah. You get the real part is cos alpha cos beta minus sine alpha sine beta, and the imaginary part is I times sine alpha cos beta plus cos alpha sine beta. Now this is none other than the angle addition rule for cosines. This is in fact equal cosine of the sum, alpha plus beta. And similarly, this, by the angle addition rule for sines, is sine of alpha plus beta. So this is cos alpha plus beta times I sine alpha plus beta, and therefore it's cis of alpha plus beta. Just a second, it came in. So cis alpha times cis beta equals cis of alpha plus beta. That makes it a lot very simple. Multiplying these cis's is really quite simple. You just add the angles. And just like multiplying sis's adds the angles, dividing the sis's subtracts the angles. Cis alpha over cis beta is cis of alpha minus beta. And a power of a cis, well, a power is a repeated multiplication. That turns into a repeated addition, which is multiplication. Cis alpha to the nth power is cis of n alpha. Now from this, we get some rules. If you have a complex number r in the form r cis alpha and multiply it by another complex number s cis beta, well, r times s multiplies, and cis alpha times cis beta is cis of alpha plus beta. So you multiply the lengths and you add the angles. Now, similarly, when you divide two complex numbers, the lengths divide. R over S, cis of, you subtract the angles, cis of alpha minus beta. If you take a power of a complex number, R cis alpha, R gets multiplied by itself n times, so R to the nth. Cis of, you multiply alpha by n, cis n alpha. R to the n cis n alpha. So a power of a complex number is a power of the length times a multiple of the angle. So here, one complex number and another complex number, length r, length s, angle alpha, angle beta, and then their product, we length r times s, and the angle they make is alpha plus beta. Now, that makes it easy to multiply and divide and exponent and then take powers of complex numbers. There's also complex roots. So we have to sort of run this, we'll have to run this rule sort of backwards. And some difficulties will arise. Suppose you have r cis alpha, and we want to find its nth root. We want to find w, which to the power n equals r cis alpha. Okay, w will have a polar form, s cis beta. So s cis beta to the nth equals r cis alpha. We want to find what s and beta are. Okay, an nth power of s cis beta is nth power of s times cis of n times beta. S to the n cis n beta with r cis alpha. Okay, these two complex numbers are the same, so they have to have the same length, s to the n equals r. And okay, it's a little with the angle, since going around 180 to 360 degrees gets to the same number, we have to say that these differ by an integer multiple of the rotation. So n beta equals alpha plus an integer multiple of the rotation. Now, s to that equals r, so s is nth root of r. That solves that. Okay, n beta equals alpha plus what integer multiple of the rotation. The rotation is 2 pi radians, k, and let k be a whole number. So n beta equals alpha plus 2 pi k. And now, solve for beta. Beta equals alpha plus 2 pi k divided by n. And this gives you the nth roots. Nth roots of r cis alpha r, nth root of r times, just a second, nth root of r times cis of alpha plus 2 pi k over n. This k is a whole number between 0 and n minus 1. You basically will get nth roots of r cis alpha. We'll get to that. So here's some examples and we'll get to that. All right. 4 minus 4i, what's its polar form? Well, it's over 4 and down 4. And has an outed angle r, outed distance r, and it's an angle theta. All right, if you work out r, it's by Pythagoras root of 4 squared plus negative 4 squared. That's root of twice root 16, which comes out to 4 root 2. And this is an isosceles right triangle, so this is a 45-degree angle, only it's negative because it's clockwise from the positive x-axis. So put it all together, 4 minus 4i is 4 root 2 cis negative 45 degrees. That's its polar form. It's running it backwards. 2 cis 120. What's its rectangular form? Well, 120 is 60 degrees short of 180. So you have a 30, 60, 90 triangle. And if 2 is the length of the radius, this is 2, then here we cosine 60. 1, only it's negative 1 because it's to the left. And this will be root 3. So, okay, so 2 cis 120 degrees is 2 times negative half plus I root 3 over 2, which comes out to negative 1 plus I root 3. That's the rectangular form of this. Now here we have two complex numbers. Z is 2 cis 40 degrees, W is 4 cis 20 degrees. And what are their product and their quotient, and we'll leave it in polar form. All right, Z times W. Well, we multiply the lengths, 2 times 4, that's here. Cis of, we add the angles, 40 plus 20. So this is 8 cis 80, cis 60. 8 cis 60 degrees. And okay, we can expand that into its rectangular form, but this will do. Z divided by W, you take the ratio of the lengths, 2 over 4, cis of the difference of the angles, 40 degrees minus 20 degrees. This simplifies to 1/2 cis 20 degrees. All right. Now let's go a little further. Here we have 2 in rectangular form. Z is 2 plus 2I. W is root 3 minus I. What's their product? What's their quotient in polar form? All right. Z is 2 plus 2I. So the diagonal is 2 root 2. This is isosceles, so this is 45 degrees. Z is 2 root 2, so it's 45 degrees. W is over root 3 and down I. You can check that this third side is 2. We have a 30, 60, 90 triangle, and it's clockwise, so it's a negative 30 degrees. W is 2 cis negative 30 degrees. So multiplying it out, the Z times W, 2 root 2 times 2 is 4 root 2. 45 degrees plus negative 30 degrees is 15 degrees. ZW is 4 root 2 cis 15 degrees. Z divided by W, you take the ratio of the lengths. 2 root 2 over 2 leaves the root 2. And cis of the difference, 45 degrees minus negative 30 degrees. 45 degrees minus negative 30 is 45 plus 30 makes 75. So Z over W equals root 2 cis of 75 degrees. Now, here we have the third power of 4 cis 40 degrees. All right, and they ask for the rectangular form. So, all right, first we distribute the 3 over the 4, 4 to the third power, and cis of 3 times 40 degrees. 4 to the third, cis 3 times 40 degrees. 4 to the third is 64, 3 times 40 is 120, cis 120 degrees. 64 cis 120 degrees. Okay, 120 degrees we saw back here is 60 degrees short of 180. And so we get cis of 120 is minus 1/2 plus I root 3 over 2. So we have 64 times minus 1/2 plus I root 3 over 2 comes to, this times this is negative 32. This times this is I 32 root 3. So negative 32 plus I 32 root 3. Here we have a fourth power of root 5 cis 3 pi over 16. Okay, so root 5 to the fourth is the length. Cis of the angle is 4 times 3 pi over 16 here. Okay, square root of 5 to the fourth is 5 to the 4/2 power. 4 times 3 pi over 16 is 3 pi over 4. 5 to the 4/2 is 5 squared is 25. 25 cis 3 pi over 4. That's 45 degrees short of 180. And so its cis is minus root 2 over 2 plus I times root 2 over 2. So 25 minus root 2 over 2 plus I root 2 over 2. Distribute the 25 and you get minus 25 root 2 over 2 plus I times 25 root 2 over 2. Here they have the fifth power of 1 minus I. What is that? Well, 1 minus I is over 1 and down 1. Its diagonal is root 2. The angle is minus 45 degrees. So root 2, cis negative 45 degrees to the fifth power. Okay, so length to the fifth power, root 2 to the fifth. 5 times the angle, cis 5 times negative 45 degrees. This is 2 to the 5/2, cis negative 225 degrees. All right, we'll add 360 degrees, 225, and get 135 degrees. 2 to the 5/2 is 2 squared times 2 to the 1/2, which is 4 root 2. cis 135 degrees is 45 degrees short of 120, so you get minus root 2 over 2 plus I times root 2 over 2. So this is 4 root 2 times, this is minus root 2 over 2 plus I times root 2 over 2. Oh dear. Oh, right. Then if you multiply it out, some root 2's cancel out. Some root 2's multiply out, and then they cancel against 2's. And you get minus 4 plus I times 4 to the 5th power of that. Wow. Here they ask for to solve the 4th root of 4 minus I 4 root 3. This thing over here, 4 minus I 4 root 3. It's over 4 and down 4 root 3. But if you check the radius, it's 8. Square root of sum of squares of these, you can see 8. This is a 30, 60, 90 triangle, so this is a negative 60 degrees. So w to the 4th is 8 cis negative 60 degrees. All right, so w has to have a 4th root of the 8, 4th root of the length. Cis of, okay, 1/4 of the whole way, negative 60 degrees, but also all those multiples of 360 degrees. So really, I should say cis of negative 60 plus 360 k degrees for here. So we take 1/4 of that. All right, and then this comes out to 8 to the 1/4. 8 is 2 cubed. This is 2 to the 3/4 cis of, this works out to 15 degrees plus 90 k degrees. So this is at a length, this is a circle, the radius 2 to the 3/4. Here's one at negative 15 degrees. Here's one at 90 degrees later, counterclockwise at 75 degrees. Add another 90 degrees, you have 2 to the 3/4 cis 165 degrees. Then another 90 degrees, you can see here, 2 to the 3/4 cis 255 degrees. Note that these are arranged in a regular 4-sided figure, because we divide up 360 evenly into 4 parts. Here, 5th roots will wind up dividing the circle up into 5 equally spaced parts. So find the complex 5th roots of I. So w to the 5th equals I. And that's I is 1 cis 90 degrees. Or cis 90 plus 360k degrees. So taking the 5th root, we take the 5th root of the magnitude, 5th root of 1, cis of 1/5 of 90 plus 360k degrees. You add this in because again, that gives you the same thing, and you'll wind up finding basic what are called roots of unity. All right, so this is 18 degrees plus 72k degrees. Cis of that times 1 is w. So you have cis of 18 degrees, cis of 90 degrees, cis of 162 degrees, cis of 234 degrees, cis of 306 degrees, all spaced on the unit circle.